that we're building on today, our learning target is that we're solving quadratics with complex roots. So taking a look here at example 1, we have x squared minus 5x minus 7. We want to get everything on one side, so we're going to minus the 5x since it's positive to move to the other side to the opposite. It's a minus 7, so we add 7 to the other side. Now, like we did in the bell ringer, we want to label the A, the B, and the C based on this problem. Here, A is 1, B is negative 5, C is 7. And let me scoot that over so you can see that a little bit better. So for us, X equals a negative 5 plus minus square root of negative 5 squared minus 4 times 1 times 7, and the whole thing is going to be over 2 times 1. All right, now if we break this apart, negative times negative is positive, plus minus square root. Let's go over to our calculator and put in everything underneath the radical without the radical symbol. So negative 5 squared minus 4, parentheses 1, parentheses 7, gives us negative 3. And on the bottom, we still have 2. Now, we've studied previously that a negative under the radical, whenever it's a square root, will come out as an I for the imaginary unit. And then the 3 stays behind because it does not break into any other perfect squares with factors. All right, so this is our answer. You can represent it that way, or we can go ahead and break this problem apart into x equals our 5 plus symbol, I radical 3 over 2. And the other answer that's trapped in there is the minus instead of the plus. So 5 minus I radical 3 over 2. So either way is fine to represent this. On your homework, you'll want to be able to actually type it in exactly how it appears here. But know that we get it from this setup. All right, your guided practice is over here to the side. It says negative 6x equals negative x squared minus 12. Now, you can pause the video and practice this and then come back. I'll come back with the answer for this portion, and I'll do that right now. So if you want to pause, this is your chance. For the guided practice on this part, just putting up my solution on the screen here. We have to get everything on one side, so you have to add the x squared, keep the negative 6x on that side where it is, and then add the 12 equals 0. Label the A, the B, the C. Plug into the quadratic formula. Here we note that negative 12 on the radical is negative 1 times 4 times 3. The negative 1 comes out of the radical as an I. The 4 comes out of the radical as a 2, and 3 stays behind since it's not a perfect square. So this answer, we see that everything is divisible by 2. So the 6 turns to a 3, the 2 turns to just a 1 that's not written, and then the 1 from the bottom that was a 2 just isn't written anymore because it's the whole thing over 1. So the answer can be written this way, or it can be written as this way right here. So you can pause the video if you need to study that a little bit more in depth. All right, our next example, example 2, has 10x squared minus 4x equals negative 10. Again, for this particular problem, we want everything on one side. So I'm going to move the 10, since it's a negative, by adding. So I have 10x squared, a minus 4x, and a plus 10 equals 0. I label the A as 10, the B is negative 4, the C is 10. Remember, it is very important to take your signs. And I'm just going to zoom in a little bit more here so it's a little bit easier to see. After we have this A, B, and C label, we can jump straight to our formula, where x equals a negative b plus minus square root of b squared minus 4ac all over 2a. So that's the formula filled in. Now we have x equals positive 4 plus minus the square root that we're going to go to our calculator and plug in exactly as it appears. So let me try to get that on screen for you. We're going to do the parentheses, negative 4 squared minus 4 parentheses 10 parentheses 10, and we get negative 384 under the radical. And on the bottom we have 20. So we move forward by breaking down this radical, and we're looking for the biggest perfect square that goes into it. The negative 1, of course, gets us the negative, and we can also use 64 and 6. I did a little bit of prep work in order to figure out what numbers to use. And again, using those perfect squares, the largest one that goes into 384 evenly is 64. So here x equals 4 plus minus the negative 1 comes out of the radical as an I. The 64 comes out of the radical as an 8, and then you've got 6 that stays behind since it's not a perfect square. 20 is on the bottom. Now, if you're looking here, you have a 4, an 8, and a 20. And you're looking for the number that goes into all of those, and it's going to be 4. 4 goes into itself once. It goes into 8 twice. And it goes into 25 times. So this is one way to represent your answer. The other way would be separating it out. X equals 1 plus 2i radical 6 over 5. And I do a comma, and I do 1 minus 2i radical 6 over 5. And on your homework, you're going to want to represent it the second way where you break it apart. All right, at this point, we're going to move over to the guided practice 2. Guided practice 2 on your paper reads, negative 2x plus 5 equals negative 5x squared. I would go ahead and pause the video and practice this and hit play when you're ready to go through and check your actual answers, which is what I'm going to be jumping to next. All right, so let me go ahead and project this up here for you all to see. Make sure I get it all in one shot. All right, the first thing you want to do is actually move everything to one side. So you move the negative 5x squared, making it positive on the left. So 5x squared minus the 2x you had plus 5 equals 0. Label A, B, C. Plug into your formula appropriately based on where A, B, and C belongs. We get a negative 96, which I make the note is a negative 1 times 16 times 6. The negative 1 comes out as I, the 16 comes out as 4, and 6 stays behind. 2, 4, and 10 are all divisible by 2, so the 2 becomes to a 1, 4 becomes 2, and 10 becomes 5. And then you can separate the problem out into these two pieces. If you have any follow-up questions you would like to ask, feel free to email me. I am available throughout the day. That's my first name last name at russellville.kyschools.us. Now, if you'll go to Google Classroom under the stream and check under our current chapter for the latest assignment, which will have you solving these complex roots and quadratic equations. There will be an exit slip to follow after you've practiced that. Again, email me with questions, and I hope you will have a great day.